Yes. All right. This is the robot that we took to Worlds this year. A lot of you have seen what it looks like already in person. This is the CAD version of it. As you can see, there's lots of little bits and pieces and a whole bunch of parts on there. Each piece that we design essentially would represent a single piece on this. Give you a more specific example, one of the things that we designed and 3D printed is going to be this custom backplate right here on our shooter. All right, so the back of our shooter turret is one of the parts that we had to custom design. We have some scraps of it laying around. Yes. We needed to find a way to connect two metal plates together with an arc that we had to create, right? This is not something you just buy off the shelf. So using CAD, we had to follow the designs of, we knew it had to be a specific radius, a specific size, have specific holes in the side for us to attach. So we essentially had a list of requirements, much like we have the CAD drawing, of what rules the part had to follow, which we then turned into the actual part, right? And it boils down to, not counting the custom lettering, that's a little different, but it winds up boiling down to the exact operations we've been doing today, just more of them, right? Is we started with a simple sketch, we extruded that sketch, then we added some sketches for the holes, we subtracted those, we added a few, it's all just sketches and extrudes for the most part. So this is that interior plate, just to give you a bit of a closer look at it. So the whole object started from a basic sketch where we identified some of the things that we knew about it, right? We knew how thick we wanted to make it, we knew how wide we wanted to make it, and we knew how far away from the front of the shooter we wanted to make it. And you can see all those here, right? You have in this case it's the diameter of the ball, right? Because that's how far apart we want them to be. So we have our distance from the center, we have how thick, how wide, et cetera, et cetera. And that's the entirety of the sketch. And then from there, we just extruded that. And that's where you get into a little bit of fancy stuff, right? You can extrude along a path. So instead of going in a straight line, you can make it go in a curve. And that's what we wound up doing to make it curve the way we wanted it to. You do a sketch for the holes. You punch the hole all the way through the object. All of the things that we've learned how to do today, you can use those exact tools to create this, with the one thing we haven't covered being how to do fillets and chamfers on an object, which is just rounding out the corners of an object. And those are what these different round bits on here, these different curves. You can draw that in the sketch if you want, or when you have the object, there's a tool, well, it's because we're on a version. So this is kind of the last thing that I wanted to cover. Right? This is something called a fillet, or fillet, however you pronounce it.
Fillet.
Yeah. Depends on if you're talking about fish, or if you're talking about food or manufacturing. So the purpose of this is to round out a corner. Right? If you select a line on your object, and then you have the fillet tool, this thing, that will add rounded parts on it. So if I click this corner, it turns it into a rounded object. And it's doing it to, he's got all sorts of fancy stuff on here. Just make it a little simpler. So your standard fillet is going to be a radius around whatever line you select. Right, so this radius is some tiny, it looks like 3 millimeters? No, 0.3 centimeters. So it's going to take your object and it's going to curve the line that you selected by whatever your radius is.
3 millimeters.
Is it 3 millimeters? Okay.
3 millimeters.
Losing track on that distance. If I come over here and oh, there you go, 1/8 inch. If I come over here and I change that number to just 1 inch, it gets real angry at me because the rounding is bigger than the part, right? You can only round something if you have enough material on it to cut off. So that's way too big. Oh, 1 meter, excuse me. 1 meter is way too big. That's 3 feet. This whole part is 1 inch wide. So if I come back and I change this to a more reasonable, we'll say 1/4 inch. So you can see now it's a much bigger rounding on there. You can use this to control your corners, and the reason that we do this, the reason that we fillet things is because if you leave things on a point, they're sharp objects. And sharp objects are a danger to us, right? You can cut yourself on them. They don't meet safety requirements, especially for robotics. So in general, whenever we have a part, we have a rule that if I just kind of hit myself with it and it hurts me, it's too sharp, right? And we don't want you actually testing that, because if it is too sharp, you're going to hurt yourself. But if I can't run my hand over it, then it's not a safe object. So if you see this, it looks like it comes to a point, but if you look at it closer, it actually has a fillet on the point of it to keep it rounded. We can pass this around in a second. And we do the same when we make things out of metal too, right? If we go cut a part, we have to take it on over to the grinder and round that cut all over, so that's not sharp and it doesn't pose a danger to us.
You especially do this when you make things out of metal, so it really doesn't hurt you.
Yes, it is even more important than when it's made out of metal, because that stuff's even more dangerous than plastic. When you apply 3D printing, which is something called additive manufacturing, where you add material onto a part to create it, there's all sorts of considerations for if you have, like you said, if you have a corner, that's a lot more fragile than if you have a rounded edge. And later on in the summer, he's going to be teaching some lessons on 3D printing design, where he'll be going over in more detail things to consider when you're 3D printing, like rounded corners, how to lay out your print so that it's stronger, which way layer lines go, and all that kind of stuff. In terms of CAD, right, mainly currently we're using CAD for 3D printing or CNCing material, which means either cutting it out of metal or printing it out of plastic. And in both cases, fillets are used to round corners out for safety. They're also used for other things, but primarily for safety. I'm going to cancel this so I don't break something. There you go. So that's an example of why you want to cancel something instead of saving it. Is I didn't actually want any of those changes because they would break a whole bunch of stuff on the robot, which is why I canceled out of it. So if you're wondering why they include that button, if it just deletes all this stuff, it's because sometimes you're just messing around and you don't want to save it.